Hi, Greg Burkhart, Director of Safety and Training at the AGC in Northwest Ohio. I'd like to talk today about confined space in construction. For years, the confined space standard that we used in construction was out of the General Industry Standard 1910-146. At that time, it was considered state-of-the-art up until 2015, when the confined space standard for construction came into effect, 1926-1200. The new standard went into effect fall of 2015. And OSHA estimated that if we comply with that standard, we will annually prevent 780 lost work days, 5.2 fatalities, saving families, workers, and employers $93.6 million. The definition of a confined space is the same in both general industry and construction, and also the definition of a permit required confined space is the same in both general industry and construction. 29 CFR 1926-1200 is the new standard for construction. What I'd like to talk about right now is simply how the two come together. The definitions are the same. There are just a few workarounds that they've added into the construction industry requirements. And one of those workarounds is a competent person must do an initial job assessment at the site. Continuous air monitoring of confined space must be performed, and continuous ventilation also must be used. Information about those confined spaces must be shared between all employers, and we'll get into those definitions and all of that here in a little bit. And then coordination with the rescue teams also must be in place. Some interesting statistics. Confined space entry is 50 to 100 times more dangerous than any other type of industrial operation. And 80% of those confined space fatalities happen where an individual has already entered into that confined space previously, the same person, the same space, and they have perished in that space. And in fatal confined space accidents, only 7% of the locations had warning signs indicating that they were confined spaces. 40% of the confined space fatalities resulted from atmospheres that are oxygen deficient, and 40% of the fatal atmosphere accidents, the hazard was not present at the time of the initial entry. And what that indicates is we've created the hazard in the confined space. So the work we are doing is what created the hazard that are killing our construction workers. In 64% of the cases, the task could have been accomplished from outside of the confined space. Some of the classes that I have taught, I've had people give me examples of the item or the entry that they make, and they give examples of where it could have been changed so that they didn't even have to make the entry. Remote monitoring is one of them. Monitoring water flow. Individuals had to go in and actually monitor the water flow, measure the water flow, when they knew that they had equipment available to do that remotely. So these are just some of the things that we have to think about when we're doing confined space entry. Can we completely eliminate the entry? What is a confined space? And here again, general industry and construction define a confined space as the same. Large enough and so configured that an employee can bodily enter and perform the assigned work. That means they have to be able to actually get into the confined space. 5-gallon bucket, not going to happen. Not considered a confined space because you physically cannot enter that confined space. Has limited or restricted entry and exit means. That means one way in, one way out. It also means I have to use a ladder, or I have to contort my body in any way, shape, or form to be able to get into that confined space. It's not just simply opening a door. And it is not designed for continuous human occupancy. So a large basement, one way in, one way out, but yet it can be designed for continuous human occupancy. So that would not be considered a confined space. So all three of these have to be met. Large enough to enter, limited or restricted entry or exits, and is not designed for continuous human occupancy. Some examples of confined spaces: bins, boilers, vessels, septic tanks, concrete pier columns, transformer vaults, turbines, anything like that. Manholes, things that are not usually entered. And like I said before, any way, shape, or form you have to contort your body to get in, use a ladder, those are considered examples of confined spaces. Now, a permit required confined space, any one of the following 4 characteristics classifies this as a permit required confined space. Contains or has the potential to contain a hazardous atmosphere. Oxygen deficient, hydrogen, nitrogen enriched, carbon monoxide, anything like that, hazardous atmosphere. Number 2, contains a material that has the potential for engulfing an entrant. Is it a flowable material, such as grain, sand, even water? Has an internal configuration that an entrant can be trapped or asphyxiated by inwardly converging walls or by a floor which slopes downward and tapers to a smaller cross-section. Some type of a silo. And then the last one, contains or any other recognized serious safety or health hazard. That is OSHA's catch-all. Any serious safety or health hazard. So, just to quickly repeat that, contains one or more of the following: contains or has the potential to contain a hazardous atmosphere, contains a material that has potential for engulfing an entrant, whether it's liquid or solid, an internal shape, configuration that can entrap or asphyxiate an individual, and any other serious recognized safety or health hazard. That qualifies that space as a permit required confined space. OSHA's definition of an entry: anytime you break the plane of that vessel or that opening, you have made entry, whether it is intentional or accidental. So when you have an attendant that is handing you tools and his arm or his hand passes through that opening, he has officially or she has officially made entry into that confined space. So keep that in mind as an attendant helping an individual, helping your entrant into the confined space. Hazards resulting in 670 confined space deaths. These deaths occurred between 2012 and 2016. There were 670 confined space deaths. Atmospheric problems contributed to 55% of these deaths. And when I say atmospheric problems, I simply mean oxygen deficient, nitrogen enriched, carbon monoxide, hydrogen sulfide, anything like that. Something that can asphyxiate an individual. 34% of the time it was loose material. Silos, pits, things like that with flowable material. And 11% of the time it was other items that caused that death. 100 reasons for entry into the confined space, related deaths. Routine maintenance was the large majority of that, and repair. Inspection to retrieve objects. There have been documented cases where an individual has passed away in a confined space after they have dropped something, such as their hard hat, into there. And last was firefighting. Most common atmospheric hazards in confined space is hydrogen sulfide, with 77 deaths, 37% of the time. Carbon monoxide, 29% of the time. Other gases, 21% of the time, and gases not specified, 13% of the time. So hydrogen sulfide and carbon monoxide are the two gases that have the largest impact on confined space deaths. So what is a hazardous atmosphere? Flammable gas, vapor or mist in excess of 10% of its LEL, lower explosive limit. Airborne dust, so that you can't see your hand in front of your face. The 5-foot rule. If you can't see your hand in front of your face, OSHA classifies that as a potentially explosive atmosphere. Oxygen concentration between 19.5% or above 23.5%. When we turn on our air monitors, it should read about 20.9 or 20.8%. Atmospheric concentrations of any substance for which a dose or PEL is your permissible exposure limit over an 8-hour period, is published in Subpart D and Subpart Z of the 1926 standard. So if you know what the gas is in a vessel that you're entering, you can look that up in Subpart D and get the permissible exposure limit. Permissible exposure limit for carbon monoxide is 35 parts per million in an 8-hour period. Hydrogen sulfide, it is 10 parts per million in an 8-hour period. And we will talk about that when we get to talking about air monitors. Immediately dangerous to life and health. Any atmospheric condition that achieves that designation of immediately dangerous to life and health, that simply means an environment where you cannot stand in and expect to live. The best example I can come up with is walking into a smoke-filled room. How long can you stay in a smoke-filled room? You don't. You immediately leave. That classifies that as an IDLH atmosphere, immediately dangerous to life and health. And then you can garner any information off your safety data sheets, the older MSDSs, if you know the environment you're going into and possible exposures to what was in there before. Those are my hazardous atmospheres. So the flammability range, that is the explosive limits, the upper and the lower explosive limits. The UEL, the maximum volume percent of a material in air, which that air will burn or will ignite. And the lower explosive limit is the minimum volume percent of that material. Take a look at the chart on the screen. And you can see that anything under the LEL would be too lean to burn, would not have enough air in it. In UEL, my upper explosive limit, it would be too rich to burn. But in between is my explosive limit. The explosive limits of some, or flammability ranges, I should say, of some of our more popular gases that we may be exposed to, acetylene being one of them. Lower explosive limit of 2.5%, where my UEL, my upper explosive limit, is 100%, which makes acetylene a very unstable gas. Even carbon monoxide has a flammability range of 12.5%, all the way up to 74%. So anywhere between 12.5 and 74, it has a flammability range. Propane, 2.1 to 10.1. So if you know the vessel you're going into, if at one time that it contained acetone, you know that the explosive limits, you don't want to be in there during those explosive limits between 2.6 and 13. My solids and my dusts. Combustible dust, extremely deadly. Flammability is very high, and there are absolutely no monitors out there like there are for air monitors for measuring carbon monoxide and oxygen. There are no monitors to measure the combustibility of combustible dust in the air. That's why OSHA says 5-foot rule. If you can see your hand in front of your face, you're okay. If you cannot, you are in potentially an explosive atmosphere. Several years ago in Georgia, there was an explosion at a sugar plant down there. It killed, I believe, 15 people, simply because the dust had accumulated from sugar moving through the plant, and they were not cleaning the plant beams, conveyor belts, and things like that in a timely fashion. And it killed 15 people. Our oxygen concentrations, like I said, when you turn an air monitor on, it's going to read about 20.9 or 20.8%. That is the air that we normally breathe. Our air monitor, when we turn the air monitor on, will find that oxygen level, and if it's 20.9, it will continue on with its testing of toxic atmospheres. LEL first and then toxic atmospheres. But if our oxygen concentrations are above 23.5% or below 19.5%, our air monitor will alarm. Oxygen deficient atmosphere, 19.5%. Can we survive in an atmosphere like that? Yes, we can, but it's going to be for a short period of time. Decreased ability to work strenuously, impaired coordination at 15 to 19%. So it will alarm at 19.5%. All the way down to 16.5%, sufficient to sustain life. After that, things start falling apart. Respiration increases, poor judgment, and on and on and on. We want to be at 20.9 to 20.8% on our air monitor. If the alarm goes off at 19.5%, we need to step back and we need to take a look and see why that has dropped. What gas has replaced 1.4% of our oxygen? Oxygen can be consumed simply by things that we're doing. Hot work, are we welding in that vessel or in that confined space? Breathing, simply breathing depletes the oxygen. If we do not have air moving in there, if we don't have ventilation, if we don't have oxygen coming in, we can deplete that. That will not show up on our monitor other than with a depletion of the oxygen level. The 20.9 will be dropping. It does not pick up carbon dioxide, which is what we're breathing out. Chemical reactions, simply the melting or the rusting process of metal. Biological action, decomposing organic matter. Hydrogen sulfide can be created by the decomposition of organic matter. And any other man-made substance in there. Are we cleaning? Have we taken a solution down there to clean something? With the work we do in a confined space, we can simply deplete the oxygen by doing that. Oxygen-enriched atmospheres, anything above 23.5%. So our monitor won't go off until it gets to 23.5%. So we are enriching the enriching the atmosphere with oxygen. And when we enrich the atmosphere with oxygen, we promote combustion. Items will burn more violently if they are oxygen enriched. Hair, clothing, materials, things like that. Oil-soaked rags, anything that is enriched with oxygen will burn more violently, even with a smaller spark. We never use oxygen to ventilate, and we never store or place compressed tanks in a confined space. If we ventilate, we simply use a fan pushing atmospheric air into our confined space. We never, ever use oxygen to ventilate. The air that we breathe, normal air concentrations, nitrogen, 78% of the air that we breathe is made up of nitrogen. Oxygen makes up 20.9% of that. And then go down the list, argon, carbon dioxide, neon, all of that stuff make up the air that we breathe. Nitrogen is used on a regular basis to purge vessels of contaminated air. Unfortunately, nitrogen is one of the things that kill our construction workers. They purge the tank with nitrogen, do not check the atmosphere in that tank with an air monitor, and the nitrogen is still way too high with not enough oxygen in there. And that's when people become asphyxiated due to lack of oxygen. Unfortunately, it happens way too often. Carbon monoxide. Like I said before, 35 parts per million is our permissible exposure limit over an 8-hour period. So if you turn your air monitor on and you get above 35 parts per million, you know you have an atmosphere that has carbon monoxide in it. Carbon monoxide is the byproduct of any combustion process. So keep in mind, if you have a generator or a welder running nearby and that exhaust is getting into your confined space, then you could be enriching that confined space with carbon monoxide. Hydrogen sulfide, that rotten egg smell, byproduct or decomposition of organic matter, the more you breathe hydrogen sulfide, the more it deadens the sense of your smells. So you may be in an environment high in hydrogen sulfide, you identify that, you take a few more deep breaths, and you say, oh, I don't smell it anymore, it must have gone away. It does deaden the sense of smell. And that's only at 10 parts per million. Our air monitors will alarm at 10 parts per million for hydrogen sulfide. Atmosphere analysis. Let's talk a little bit about vapor density. The weight of a flammable vapor or gas can be found on your safety data sheets. Scientists have labeled air, the normal air that we breathe, as 1. So any substance like 0.7 will be lighter than air, and it will be found near the ceiling. Any substance heavier than air, with a vapor density of, say, 1.4, will be heavier and found near the floor. Is this a big deal? This is a huge deal when it comes to entering into a confined space. We may have good air at the top, and we may have toxic or even explosive air at the bottom. Propane, for instance, is heavier than air. It will be at the bottom of a vessel. It will be at the bottom of a basement. So keep that in mind. Your gas grill's outside of a basement window. If you leave it on all the time and it springs a leak in the hose, gets in the window, it's going to be hovering around the floor of your basement. How do we test the atmosphere? First of all, we need to understand our air monitor. It's not one of those things you turn on and you just let it work. You have to understand your air monitor. Read the instructions, check the owner's manual for the time that it takes for that air monitor to start testing the air. Some air monitors come with a pump. A lot of them come with a pump, and they'll have 20 or 30 foot of tubing on it. Read the owner's manual to see how long it takes that pump to bring that air through that 20 or 30 feet of tubing. When you turn on your air monitor, there is an order of testing. And like I said earlier, it tests the oxygens first, and once it establishes the oxygen at 20.9 or 20.8, then it will test the combustibles, and then it will test your toxic atmospheres if there is any toxic atmosphere. So what type of hazards are we looking for? Well, the biggest thing is our oxygen deficient atmosphere, our combustibles, which is our UEL and our LEL. Combustible, the LEL monitor will monitor at 10% of our LEL, which allows us to get out of the vessel or the confined space with still 90% range as a safety factor. If we know the vessel that we're in, we may be able to test for that atmosphere. Stratified atmospheres, I refer back to the vapor density. Figure out how heavy the air is, how heavy the material that you're in the vessel, and figure out where you're going to be as far as is it heavier than air or lighter than air. We must test our air every 4 feet. So put little pieces of tape on that 20-foot hose, drop it down 4 feet, put your tape every 4 feet, and wait the designated time. Wait until that monitor alarms or doesn't alarm. If it says wait 20 seconds, wait 20 seconds. Get your reading, write it down, drop it down another 4 feet until you're near the bottom of the vessel. Remember, do not ever put this hose in liquid. So, here's a question. How quickly can the atmosphere change in my confined space? It can change extremely quickly depending on the type of work you're doing and the atmosphere that you're working in. Atmospheric testing shall be performed initially and just prior to entry. If you're entering, say, into a manhole, you must test the atmosphere, test around the atmosphere prior to sliding that manhole cover off. There are videos on YouTube of people sliding a manhole cover off that happen to have an explosive atmosphere in the manhole, and it exploded because of the spark sliding the manhole cover off the manhole. Continually and recorded at least every 2 hours for permit required confined space. That's per the OSHA example. Our recommendation is to record your readings every 15 minutes. 20.9 is our normal breathing air. If we are working in an environment that potentially is bringing in or we are making a hazardous atmosphere, we're going to lose almost 1.5% of our oxygen before that alarms. How quickly can that happen? We really, really have to monitor that and keep an eye on that. So we recommend 15 minutes on the permit. Every 15 minutes, record. It should read 20.9000. Here's a good picture of stratified atmosphere. At the top, we could have good air. In the middle, we could have poor air. And at the bottom, we could have our deadly air. This is why we must measure our atmospheres in especially a vertical vessel every 4 feet. Horizontally, we should also try to measure every 4 feet. We can have pockets of bad air, toxic air, or explosive airs in a horizontal vessel also. So please keep that in mind too. These air monitors are rather expensive, somewhere between $1,200 and $1,800 a piece. But if you're not wearing them and not using them properly, they are absolutely useless. So air monitoring is the best thing we can do to create a safe environment in our confined space. Moving on to engulfment hazards. Unfortunately, this is one of the things that a lot of farmers, a lot of co-ops have problems with. People feel that they can walk on the top of a silo that is filled with grain or soybeans or whatever, even sand, even at batch plants and things like that. And what happens is these bridge over and collapse when they put that extra 200 or 250 pounds on them. When you are engulfed in a confined space, the pressure on your chest makes it impossible for you to take a breath. And this is how a lot of people are passing away in engulfment hazards, is because they can't breathe. We can also have engulfment hazards in liquids. So keep that in mind. Anytime you have the potential for a flowable material, we must be protected, and it is considered a permit required confined space. Here's a question for you. Take a look at the picture. Is that a confined space when you're walking on the catwalk out to that motor? By the definition of a confined space, it is not. But just think about a couple things here. What is that liquid in that vessel? Is it toxic? Is it depleting the oxygen? Is it replacing the oxygen? How do we walk out there and safely perform our job if we have to do something on that electric motor? Flowable materials, they pull from the bottom, which makes it difficult to see if there's any voids under there. And when we do identify that the material is not flowing, unfortunately, people do walk out there, and that's where we have problems. That's where the material gives way, and they are sucked down into the bottom with the pressure on their chest, unable to breathe. This is a good example of a rescue barrel. When somebody gets caught in a flowable material situation like this young lady, they have barrels that they put around them, and then they suck that material out so they're able to breathe. There have been documented cases where people have suffocated with their head above the flowable material, such as grain or sand or whatever, but the pressure on their chest did not allow them to take a breath. Or a design that can entrap or asphyxiate an individual. Trying to move through that, I can speak firsthand that is very difficult to do, but this is part of classifying it as a permit required confined space. And any entrapment hazards. Like we talked about earlier, the walls that converge, if somebody slides down into that, how difficult it would be for them to get out of that situation. Or any other recognized hazards. Electrical, steam, environmental, moving hazards. Are we creating hazards in a confined space? Just some questions that we have to ask so that we can make that confined space the safest we can possibly make it prior to any type of entry that we make into that confined space. Other recognized hazards. Fires. Are we welding or cutting in there? Remember, oxygen deficiency or even oxygen enrichment if we're welding in there. Chemical hazards. What is in the vessel? Can we identify what's in the vessel? Is it heavier than air? Lighter than air? Falls from heights. Are we in a vessel so large, a water tower, that maybe we need fall protection in there? Temperatures, hot and cold. It may be warm outside, but cooler inside. Noise, vibration, jackhammers. What type of work are we doing to create the noise? Or radioactive or biohazards. Energy, lockout, tagout. Is it electrical energy, mechanical energy, pneumatic energy, hydraulic energy? What is in the confined space? And are we able to control that? Lockout, tagout, always make sure we control the energies in that confined space prior to entry. This should all be on the permit, which is what we will talk about here in a little bit. The responsibilities. Inform our employees of the hazards in a permit required confined space. Have a training program on there. We cannot just walk up on a job site in the morning and say, yep, permit required confined space, jump in. We must have training and inform the employees of all the hazards. Develop and implement a written program. Atmospheric monitoring. Remember, 55 to 60% of all fatalities happen because of an atmospheric problem in confined spaces. If we simply monitor the air and provide ventilation, we could potentially be eliminating 55 to 60% of the fatalities. Continuous air ventilation is used. That's in the new construction standard, and continuous air monitoring is used during entry. Attendants. People have to understand that the attendant is, in my mind, the most important person on a confined space entry. They monitor the work from the outside. They help the entrant. They count the entrants. They make sure that everything is safe for that entrant. Any rescue plans, procedures in place, completed and post the entry at the entry site. It is a check and a balance. We write down everything about that permit, about that confined space that we know on that permit, and we leave that permit right there at the site. Retrieval system to remove the entrant. This is by far one of the most important things that we can do to make sure we have a safe entry at a confined space. Tripod, a davit arm system, put the entrant all entrants in confined spaces that go into confined spaces, put them in a harness for simple retrieval. The OSHA standard says that a retrieval system must be in place for any vertical entry deeper than 5 feet. I can promise you, you will not be able to pull anybody up with a rope that has passed out in a confined space. We've tried it during classes, and it just doesn't happen. We don't have the body strength to be able to do that. Retrieval systems are needed for a proper entry into a permit-required confined space. Employer responsibilities: evaluate the workplace, identify all permit-required confined spaces. This is very easy to do in a general industry setting where we have our confined spaces. We've identified them. They don't change. They don't change. They may be a pit that accepts greasy water for whatever, and that's always going to be there. Confined spaces and constructions change because we build the confined spaces. We add things to the confined spaces during the construction process. So each workplace must be evaluated for the permit required or non-permit required confined spaces. Make the locations and dangers of those spaces known to all employees. In that greasy pit, we may call that P1 for production 1. We will identify that. We will give the size of that, the entry positions of that, the hazards of that place, and on and on and on. That is by far the best way to do that. If you're working in a facility that has confined spaces and they tell you you need to work in that confined space, whether you're painting the confined space or running wires through the confined space, ask what the hazards are in that confined space. It is the owner of that confined space. It's their responsibility to evaluate that and to issue permits with the hazards on those permits. And signage. Make sure there are signs on these confined spaces. Danger, confined space, enter by permit only, no entry allowed, whatever the case may be. They should be signed to protect our workers. Employer responsibilities continued. Employees will not enter the permit-required confined space, then takes measures so they cannot be entered, whether it's through thorough training or putting a lock on that confined space. If they will enter in it, then they need the training. What type of training do they need? What is the space they are entering? Make sure we have an established written program and an entry permit system. Remember, entry permits shall be posted at the site. It is a check and a balance. Entrants, attendants, supervisors all sign the permit. We put down there the hazards that are in that confined space. These are all things that should be on the permit. All employees required to enter into a confined space or enclosed spaces shall be instructed as to the nature of the hazards. Remember, this is all about the training. At no time should any employee enter into a permit-required confined space without proper training. That is the responsibility of the employers. Personnel roles in operations. The entrant, that is the person going inside and doing the work. They should be comfortable with confined spaces. They should know what they're doing. They should be taking their proper tools down there. They should be comfortable in harnesses. Remember, it is up to them. It is their ultimate responsibility to know what's going on in there. The attendant, they're sometimes called the hole watch. These people remain at the point of entry at all times and monitor that confined space. They are the most important position. They will summon rescue. They are not part of rescue. At no time do they make entry into the confined space. An interesting statistic is 60% of the fatalities in confined spaces are would-be rescuers. And a lot of those are the attendants that make the wrong decision to help out, and they end up dying trying to help their friend. Supervisors verify that safety precautions are met. It's their ultimate responsibility to make sure that that entry is safe. And rescuer, if it is needed, it is simply just that, somebody who will rescue those individuals in the event of a problem. All right, duties of authorized attendants. I know we touched on this. I'll keep this short. Knows the hazards of the confined spaces. So they have to understand what they're getting into. Knows how to properly use all the equipment. I cannot sit here and tell you how to use all this equipment. That is a hands-on portion of a class. The harnesses, the retrieval systems, the air monitors, the tripods or davit arm systems, whatever we're using, it needs to be a hands-on portion of the class. Maintains communication with the attendant. That is by far one of the most important things between an attendant and an entrant in a confined space is they must maintain communication. They can maintain that by verbal communication or tugs on the rope or whatever they need. If it's in a large confined space, then accommodations must be made, some type of an electronic wired system in order to maintain communication between the attendant and the entrant. Alerts the attendant whenever situations come up, warning signs, their air monitor goes off, they don't feel comfortable or anything like that, they must notify immediately their attendant. The attendant must start making accommodations to get that individual out as soon as possible. And he will exit the space as quickly as possible too. As soon as the order is given to evacuate, he needs to get out of there because, like I said, it takes a little bit of time to exit out of a confined space. If your monitors are activated, you need to understand, you need to be able to read the monitor and understand what you're looking at. And whenever situations begin to deteriorate, whether it's above the ground or below the ground. Think about working in a manhole, in a sewer system. In 4 blocks up the road, a gasoline tanker tips over and starts spewing gasoline or diesel into that same sewer system you're working in. Do you know it? You may not know it until the fumes and the liquid gets to you. However, your attendant standing on the ground will see that, may see that, and be able to get you out as quickly as possible. These are just simple things that we have to think about and we have to be good at. Duties of the attendant. Like I said, this is by far the most important person in a confined space entry. Knows the hazards of the entry, the hazards of the confined space, is aware of any possible effects of the hazards over the exposure. What type of exposure is it? What atmosphere are they working in? Are they working in an engulfment potential? Things like that. They must understand all of that. Maintains an accurate count of the entrants on those permits. Entrants will put their name on a permit when you leave and when you enter into a confined space. Remains outside the permit at all times. Communicates with the authorized entrants and rescue if necessary, as well as the supervisor. Like I said, monitors activities inside and out, summons rescue, performs non-entry rescues only. And that is, I'm going to crank you out of there. You're still hooked up with your harness and your retrieval system. I'm going to get you out of there. That is my rescue. Updates the permits as things go, 20.9000. Remember, 20.9 is my oxygen level in that confined space. I have 0% on my LEL, which is my lower explosive limit. I have 0% on my carbon monoxide and 0% on my H2S, my hydrogen sulfide. Verifies that the space is safe for entry and oversees the entry operations. That are the duties of the attendant. Duties of the supervisor. Knows the hazards of the confined space. Verifies that all the tests have been completed, the equipment is there, the training is in place, the permit will be there. This is his job. He is ultimately responsible for everything on that confined space. He will terminate the entry if he feels necessary. If he gets information from the attendant that something is going wrong, he must immediately terminate that permit. Verifies that the rescue services are available, removes unauthorized people, coordinates all involved with the entry, oversees the entry to ensure it is correct, and obviously is responsible for all those involved in the entry. Like I said, the most important person is the attendant. I can't stress that enough. You want to get the person there that understands confined spaces. You want that person as your attendant. Let's talk a little bit about a permit. I keep saying permit, permit, permit. When a lot of construction workers think permit, they think they have to go to Lucas County or Wood County or wherever to get a permit to do this. This is an in-house generated piece of paper. If you follow the permit, it just is documents compliance with the standard and authorizes the entry. Like I said before, it's checks and balances. Be posted at the entry location, reviewed by all those involved. So before, when we open up the entry, we air monitor it, 20.9000. We make sure we have all our tools, all of our rescue equipment is available, our retrieval equipment is available. We check it. This all goes on the permit. Everybody involved with this, the entrants and the attendants, must sign the permit that they have looked at all of this stuff. It is in good working order. I cannot stress this part enough. It is a living, breathing document. It will be maintained for 1 year, and it should actually be reviewed on a regular basis just to make sure that everything went well and it's referenced for something that goes back. Information that must be on the permit, name of the permit space must be entered. So like I said before, if you're in research and development and you have RD1, because that's research development, permit 1, space 1, or space 2, or space 3, or whatever. The purpose of the permit, what are we doing? Are we painting inside that space? Are we adding electrical equipment inside that space? Are we cleaning a sewer in that space? The date and the authorized duration of the entry permit. This is a little bit different between construction and general industry. You can suspend a permit in construction, but you must terminate that permit in general industry. The date and the authorized duration of the entry permit. Authorized entrants and attendants, supervisors. We must identify the hazards, safety precautions, identify the results of the initial and periodic tests. Remember, please record your findings every 15 minutes. A permit required confined space permit does not have to be pretty. If you run out of space, flip it over and write it on there. That's at 2:15 we had 20.9000. At 2:30 we had 20.9000. Does not matter how pretty it is. Make sure it's written down. Rescue and emergency services. If that is needed, do we have a phone number? Have we contacted rescue and emergency services? Do not ever rely on 911 to be your primary rescue service, because I can tell you from experience, most fire departments do not have a confined space rescue team. The brain can only survive without oxygen for 4 to 6 minutes. It would take them much longer to get there and to initiate a rescue than the 4 to 6 minutes. They will come if called. Fire departments will always come if called. But please keep in mind that they should not be your primary rescue. Communication procedures. What are we using for communication procedures? Is it verbal, or what are we using? Electrical, digital, electronic, wired, whatever. The tools and equipment needed, any lockout, tagout procedures that must be in place. We're going to set the acceptable levels of entry and provide contact information for those in case of an emergency. Here's an example of a permit. It's kind of hard to read, but remember, these are all generated in-house. As long as that information is on there, and you can go on the web and get any permit that works just fine in confined spaces. So, how do we control our atmospheric hazards? First of all, let's identify the depth and the size of what we're going into. What type of openings do we have? Can we move the air? What do we need to do? Our sources of the characteristics of the contaminants. We get that through the safety data sheets and the material safety data sheets. Our weather conditions. What type of equipment do we have to be able to move this stuff? Remember, if we're ventilating, or when we're ventilating, we need the bad air to go out and the good air to come in. How do we do that? How are we going to do that? We replace the bad air with the good air. OSHA likes to see us turn this air over about 10 times per hour, I'm sorry. So how do we do it? How do we do it? Well, natural ventilation. In this situation here, methane, obviously it looks a little bit lighter than air, so it's going to be near the top of the vessel. It is going to go out the top. That's going to be our best type of ventilation, is just simply out the top. If you look in the lower right-hand corner, you see an opening there. Maybe let's open that opening and get that air to go out the top just by simply natural ventilation. Open up the bottom vessel, the bottom opening of the vessel, and let the contaminated methane flow out the top. Heavier than air, say propane, from top to bottom. So let's make sure that we have an opening in the top, we can push it out the bottom, and hopefully the guy standing there next to the opening at the bottom with a cigarette in his mouth won't explode. We have positive pressure ventilation. Make sure that the good air that we have going in from the fan is good air, and we're simply blowing out the bad air. Keeping in mind, of course, where we are standing. This is all part of proper ventilation, removing of hazardous atmospheres in a confined space. We can also suck it out, suck the bad air out, keeping in mind that we should be monitoring the air at all times. Some pitfalls, this is called short circuiting. Make sure that if we have two openings in a vessel, that we open the opening that is furthest from our fan in order to get all of the bad air out of the vessel. The air will follow the path of least resistance, so once it finds an opening, it will start leaving out of that opening, leaving the bad air in the vessel, not leaving with it. Different types of mechanical ventilation, fans that move a great deal of air. These are just things that can be used on a regular basis. We can reclassify our permit required confined spaces. If we can control the hazardous atmosphere, then there is a possibility that we can reclassify it if we can eliminate all of the hazards. And those other hazards are simply, like we talked about before, electrical hazards, steam hazards, anything that's in that vessel. Can we lock it out? Can we tag it so that it does not get turned on, so that it does not flow while we have individuals in that confined space? Can we reclassify it? We have to test the atmosphere, and we have to make sure that all moving parts in that vessel are controlled. All of our energy is controlled. So here's the deal. After we go through all that, does it really exist? Can we control it all? My recommendation is simply run it as a permit required confined space. You're safest that way. You have your permit in place. You can document your air is safe and that all of your material has been accounted for, locked out, tagged out. Now we're going to talk about construction. We're not going to talk about the confined spaces as what is a confined space, because like I said, that is all the same. General industry, like I talked about, you're going into a facility, their confined spaces have already been identified. The construction industry side is simply this. We are creating confined spaces. If we're building a building, we may be creating confined spaces. We're putting in sewer lines, tanks, things like that. We are creating confined spaces. So the contractor that goes in and creates that confined space, whether it's a steel erection company or a concrete company, they create the confined space. They report that back to the host or the controlling contractor. the competent person determines, is this or is this not a confined space? If it is a confined space, is it a permit or a non-permit required confined space? Well, we have to go back to the testing of the atmosphere, what type of machines or anything are in there. So initially built, that is just a confined space, whether it's a manhole, a vessel, a room, or whatever the case may be. That we know is a confined space. So the host employer at a meeting says, okay, we have confined spaces that have been created. The next person comes along and says, hey, I'm the plumber. I have to go into that confined space. I'm going to do this type of work in that confined space. I am changing the confined space. He's going to report that to the host or the controlling contractor. He does his work. He comes out. Competent person goes back and determines the work that he did. Does it make it a permit required confined space or a non-permit required confined space? A couple weeks later, an electrical contractor comes in and says, hey, I got to go into that space. Tell me about that space. Well, we built it as this. The plumbing contractor came in and did this, and now you're going to come in and do this. The competent person must determine, is it a permit required confined space or not? It may or may not be. I can't answer that. The electrician does his work. Maybe he has created a permit required confined space with a panel or whatever the case may be. I don't know. These are the things that we have to think about when it comes to permit required confined spaces on a construction site. What type of work are we doing to change that permit or that non-permit space, that confined space? What type of work are we doing? So now I've built the confined space. The plumber has come in and added plumbing to that confined space. The electrician has come in and added electrical stuff to that confined space. Have they made it a permit required confined space? I don't know. Now the painter has to come in. He has to get a competent person to evaluate that confined space to determine if it is a permit required confined space or not. This all goes back to the host or the controlling contractor. This documentation will stay with that confined space until the project is complete. That is one of the biggest changes in between a 1910-146 confined space versus a 1926-1200 confined space. So we've talked extensively about confined spaces today. 1910-146 general industry and 1926-1200 in the construction industry. I talk about both of them because sometimes we are either doing maintenance work in a confined space or we're doing construction work in a confined space. Remember, construction confined space, you must have a competent person evaluate your confined space. He must make determinations about the confined space. We have to report what we do in that confined space back to the controlling contractor or the host employer. And each and every time a contractor, whether it's a plumber, electrician, painter, or whoever, modifies that confined space, that information must be taken back to the controlling contractor and then shared with all other contractors, especially those who may be working in the confined space. I cannot stress enough to everybody the importance of air monitoring and proper ventilation in confined spaces. Remembering, of course, that around 60% of the fatalities in a permit required confined space are due to atmospheric problems. 60% of the fatalities in a confined space are would-be rescuers. Those are the people that get anxious because their friend is not responding in a confined space. They do something, they either enter into the confined space, well, they enter into the confined space and they are overcome or injured by the same process as what their friend is. So please, please, anytime you question whether you're going into a confined space, take a step back, And remember 3 classifications of a confined space, or 3 items that determine it's a confined space: large enough to enter, limited means of entry and exit, and is it designed for continuous human occupancy? If all 3 of those are met, then we're entering into confined spaces, which could be problematic, atmospheric problems, or even mechanical problems. Please be safe.